Hi, my name is Reid, and today I'll be going through the COMP3010 bucket incident. To provide some context, this incident occurred on August 20th, 2018, targeting the COMP3010 AWS environment where a user bypassed the multi-factor authentication, leading to the compromise on S3 storage bucket. The investigation revealed that on 20th of August, the COMP3010 webcode S3 bucket was made public accessible by the user bstol, resulting in the contents of the S3 bucket being exposed to the wide public, as well as a successful upload of a file from an unauthorized source. The investigation also revealed that 4 users accessed an AWS service at the same time of the incident, where one of the user's endpoints was running a different version of Windows. Some of the sensitive commands, such as put-bucket ACL, were also executed without the use of multi-factor authentication. For the investigation and analysis of the incident, the Splunk SIEM was used, extracting logs from the following data sources, which derived from the BOTSv3 dataset. The investigation followed the steps of the CREST cybersecurity incident response methodology, which includes taking the theory of the prevention, detection, response, and recovery phases and condensing it into 3 operational steps, known as prepare, respond, and follow up. The first Splunk query was used to establish our IAM user baseline. This query searches all CloudTrail logs and finds the users who successfully and unsuccessfully accessed an AWS service in COMP3010's AWS environment. The result included 4 IAM users with a total of 2 user accounts and 2 service accounts. The user accounts being bstol and bton, and the service accounts being Splunk Access and Web Admin. The user bstol was seen accessing an AWS service for the first time at 9:35:27 a.m. From an SOC perspective, Tier 2 will use this query for investigation when an incident occurs to check which users were online during the time of the incident, which helps a Tier 2 incident responder determine if a user or users are linked to malicious activity. The biggest vulnerability identified from the investigation was that the users were accessing the AWS API without multi-factor authentication. This unauthenticated API call means that the security of a user's AWS session relies on the strength of their password. If their password is exploited, phished, an attacker can perform sensitive operations without worrying about providing another layer of security. This vulnerability in the security controls created the initial entry vector for the incidents to take place. If multi-factor authentication was enforced, this incident would not have happened. To address this issue, firstly reevaluate the current IAM policies so they enforce multi-factor authentication on all sensitive operations, followed by creating a high priority alert from this JSON query, which notifies Tier 1 analysts anytime a user attempts to access the AWS API without multi-factor authentication. The next 3 slides focus on the S3 bucket exposure, where at 1:01:46 p.m. bstol executed the put-bucket ACL API command, which made the S3 webcode bucket publicly accessible. The event ID, seen here, marks the start of the incident, which is used by Tier 1 analysts for reference later on. Upon further investigation, the put-bucket API call was executed without multi-factor authentication, linking to the previous slide surrounding the risk of no multi-factor authentication enforcement. The S3 bucket being made publicly accessible essentially means that everything that was in the bucket, for example code, document, can be looked at by everyone on the internet. If the S3 bucket contains sensitive information such as credentials for users of the COMP3010 company or even API keys, then all that information has been linked, compromising the confidentiality of the company. This might cause the company to incur penalties for breaking regulations such as GDPR, or incur costs for repairing the damage, as well as reputational damage. The SPL query here identifies a specific log including the details of the put-bucket ACL event, involving the user who performed the event, the target asset, as well as the read-write permissions added for the public, seen here. In addition to the public bucket being made public, an external source uploaded a random text file to the COMP3010 webcode bucket. To confirm the upload of an external file, this SPL query searches through the access logs of the Frothly Webco S3 bucket and identifies any put HTTP requests. From this SPL log, you can see that at 1:02:44 p.m., 58 seconds after the S3 bucket was made public, an external source of the IP address of 52.66.146.128 uploaded the file open bucket please fix.txt to the S3 storage bucket, where the server returned 200 OK. This confirms a successful upload of an unauthorized file, confirming proof of impact, escalating the severity of the incident from a simple accident to a data breach. Beyond the primary incident, our investigation revealed some other concerns. First, a Tier 3 analyst conducting a critical assessment verified that the processor used for the web server was the Intel Xeon X5-2676 version 3 processor. The knowledge of this CPU architecture can help aid Tier 3 engineers build the proper controls against hardware-level exploits such as Spectre and Meltdown, strengthening the prepare phase of the system. Secondly, Tier 3 threat hunters identified an endpoint running a different Windows edition. This endpoint lies outside the standard security controls, which means that the device of the endpoint may have outdated software which an attacker can exploit. The host of this endpoint was also the same user involved in the S3 incident. Now I'll go over what went well and what could be improved from the whole incident response plan. What went well? So the log collection pipeline, so the CloudTrails and the S3 access log store types were complete, which allowed me to detect the multi-factor failure as well as the S3 misconfiguration, which allowed me to establish a complete timeline of the incident. The complete log sources also allowed me to rapidly correlate the S3 event with user access times, which led me to the discovery of the configuration drift issue outlined in the previous slide. What could be improved? Firstly, enforcing multi-factor authentication on all IAM policies at the API level, preventing users such as BSOL from executing operational commands without multi-factor authentication. This incident happened due to the step not being done in the first place, showcasing a failure in the prepare phase. Secondly, the discovery of an endpoint running a different Windows version suggests a lack of centralized management, so this will also need to be improved. In conclusion, the BOTSv3 incident occurred through the misconfiguration of an S3 bucket, which escalated due to the combined lack of access controls and detection implementations, which ultimately resulted in unauthorized upload of a text file and the potential exposure of sensitive company information. To address this incident, the following steps derived from the lessons section should be followed. For short term, ensuring public access to the Frothly webcode bucket have been revoked. Isolating the user bstole and endpoint bstole-l by removing BUD's IAM access keys and removing the txt file from the S3 storage bucket. For long term, adjusting IAM policies to enforce multi-factor authentication on all sensitive operations, such as the put bucket ACL event, as well as incorporating AWS's S3 block public access to prevent S3 buckets from being made public accidentally, as well as implementing automated detection of asset configuration drift to prevent users with and devices with non-standard security controls from accessing the AWS environment, and creating the SIAM rule outlined earlier using the JSON query for detecting AWS API access without multi-factor authentication. Thank you for listening.